Morning all. Well, I've got a few items of post here, so that means it's postbag time. Oh, well, it's not a PC rear mirror, it's a couple of LED drivers. Now, the first thing that's immediately apparent here is that one of these has a diode missing. There, one of the bridge rectifier diodes. This one's okay, it's got all four. This one's only got three. Now that means it wouldn't work on AC, but it should still work on DC as long as I get the positive and negative the right way round. So I'm actually going to use this one, just give it a quick try. Now I've been having trouble identifying these. They use the MC34063, but that chip can be used in buck, boost or inverting configurations. So actually I've had to revert to looking at the front of the envelope, and it says up there on the top 4 to 6 1-watt LEDs. So this is the eBay item here. It's from one of the buying coin sellers. 4 to 6 1-watt LED driver, 12 volt input. Now it was quite cheap, 62 pence. This must have been an auction, and I got two of these free postage from Rabbit SHCF. So just looking in my box of LED bits, and I found this, which is a string of 4 series connected LEDs. I think they're 3-watt ones, but it doesn't really matter. They'll just be driven at 1 watt using this driver. That fits the specification of the driver. So the important thing to note here is that this driver is using this chip in the boost configuration. So I'm going to put 12 volts in on these two pins, and the voltage coming out here will be greater than 12 volts, enough to get these things to draw exactly 1 watt. That's to say, of course, that they're going to draw 1 watt each, so in total with 4 of these things it's going to draw 4 watts. And there is some specification stuff here on the eBay listing. The input voltage is 12 or thereabouts. The output voltage will be greater than 12. Here it's saying between 12 and 20. And the current is fixed at around 300 milliamps. So here it is with 12 volts coming in from my battery bank outside. And the 4 LEDs light up. So with 4 3.3 volts, we've got more than 12 volts coming out of the boost converter driving these 4 LEDs. Now if you had 3 LEDs here, you'd actually blow them because a boost converter can't take the voltage down, so we'd be forcing 12 volts into 3 LEDs, and therefore the current would go sky high and they'd immediately fail. So with this particular driver you've got to be careful. It can't be less than 4, and greater than 6 this thing won't be able to provide the voltage required. So it is this specific 4 to 6 LED range. Now if I put this on the other connector, it doesn't work, of course, because of the missing diode. This one's got all 4, this one's missing one. So that's fine. I'm not too worried about that missing diode there, because once this is hardwired in a circuit, only 2 of the diodes get used anyway. So as long as I use it the right way around, that's fine. So that's my 4 to 6 1-watt LED driver. Now these two packages both say Fang Wei Wei, and I've got a feeling that means Banggood. These are the first items I've ever bought from Banggood. Let's see what's inside. It might be the OLED, which I bought simply because it had the lowest price of any OLED. Let's have a look. Yes, this is an OLED module from Banggood, and I bought it because it was cheaper than the one that I bought recently on eBay, and I just wanted to see if you can get a working OLED display for £3.15. So this was the item I bought on Banggood. It's since gone up to £3.21. It's a 0.96 inch white I2C OLED display module, 128 by 64, and this one is SKU 145210. So yes, that display's working. I recently, of course, did the one-day project where I drove this OLED using this Arduino Uno, using Adafruit's library for the OLED, So this is still in the Uno, so it's just a case of plugging that in, and that works fine. I'm powering it with a single cell mobile power bank, and that all works fine. The only thing I've done slightly differently this time is on the pull-up resistors. I've actually put these two 10k resistors between 5 volts and analog inputs A4 and A5, because of course on the ATmega 328p analog inputs A4 and A5 are the same as SCL and SDA, the two pins up here, the two I2C pins. So here is another Banggood item, and this one is described as charger. It's not much fun, is it, when you overanalyze the label on these things? Okay. Okay, this one's in a cardboard box. Let's do the rest of the unpacking. So let's see what's in here. And this is another single cell mobile power bank. And I bought this because apparently the battery's already in it. And with an 18650 supplied, it's a reasonably good deal. So this is Banggood's SKU 069933. Let's have a look at that one. So there's the mobile power bank I was using earlier, charging this mobile power bank, and you can see that there is a red light on, which I presume means that it's charging. That's good. Now let's try drawing some power from it. And that's working fine. I've got my torch head here. The torch is on. Now there's no switch on this. There's a switch on the torch head, of course, but there's no switch on the power bank. So that's just live all the time, I guess. Blue LED there. You can just about see the blue LED there to show that it's supplying power, and it was a red LED when it was being charged. Not much more I can say about this, but I'm kind of tempted to break this apart. It looks like it's all glued, but I'd quite like to see what battery you get in there for £2.43. So this is the item on Banggood, and I say it's £2.43 with a 9p shipping charge to the United Kingdom, so that's £2.52, but that includes the battery, and that's really quite good value. I'm going to have to break this open and see what's inside it. Well, now the plastic cover has come off. It has broken a bit because I had to pull it, and this is kind of loose, so I'm going to yank that off now. Oh, that made a nasty crack. Oh, a screw seems to have pulled out. But there's the guts of the thing. Now, what battery do we get for our £2.43? So it's welded on the bottom there. There's not much of a giveaway on there. See if you can make head and a tail of that. FB16HEL09733246, and it's an 18650 3.7 volt. Let's look at the circuitry on the board. So on the top there's a DW01 battery protection IC down on the bottom right corner there next to the inductor, and on the other side there's the 8205 dual MOSFET chip there. Now there's something here called a B3P3B, which I'm having trouble identifying. It might just be a regulator. It's that tabbed 3-pin component there, and a couple of SS14 diodes, and that's all that's on there. But the battery, because the protection components are on the board, this will be an unprotected cell, but certainly good value if it is 2200 milliamp hours, as Banggood are saying it is. Not bad value. Now I've got more than enough mobile power banks. I don't really need another, so I'm just going to try and rip this off here, and then I'll rip it off the bottom. There we are, an 18650 cell. Be interesting to test this and see how it performs for £2.50. And I've even got a couple of spare SS14 diodes, if I can be bothered to unsolder them, to put on that LED driver that was missing one. Yay! And so this pile of bits constitutes today's postbag.